us to do, it enables programming in the general rather than programming in the specific. As I just showed you, the get paint cost, instead of having specific method for each shape, I get, let's say, specific method for circle, specific method for triangle. I do one method to handle all of them. So it allows me to do generic programming, general programming, instead of having specific programming. And in here, for example, when I showed you this, thanks to polymorphism, I am able to have one list to store all the shapes. So instead of having one list for circles, one list for triangles, one list for cylinders, I have one list to store all of them. And this is only feasible because of polymorphism, because I put the data type as the superclass. Then when I want to handle them and print, let's say in this case, print the string representation or print the cost, I don't need to have multiple loops. One loop for circles, one loop for triangles, one loop for cylinders, one loop. One general loop can handle all of them. Yeah. So this is very powerful. It makes our code much more concise. And of course, it enables me to call one method, let's say get area or toString or calculate paint. One method I call, but I get different behavior based on the data type of the object I'm handling. And finally, this allows me to easily extend my program. Very easy. I can add another shape. For example, I can think of another shape, let's say a square. All I need to do, I create a shape, a square shape, extend the shape, and then ask Mr. Google, how do I do the area of the square? And then calculate the area, do my toString, do whatever I need to do. And then I'll go to the generic code. In here, zero change. In here, zero change. All I do, I come here, create an instance of the square, add it to the list, and I'm done. The general code does not change. So it makes the code much more extendable. And the same thing for this example I showed you before. In this example, if I add here a lion and a cow and a bird, and I put them all in one array of type animal, I can look through them and say talk. I don't need to change the general code. The general code to store them and the general code to loop through them and ask them to do some action or call a method on them. That is the idea of polymorphism, very powerful idea. It allows me to program in the general. It allows me to have same method with different implementation, and it allows my program to be easily extendable by simply adding a subclass and without changing the general portion of the program. Now you might be asking yourself, let's suppose I am in this shape. Yeah, I am in this shapes loop, looping through the shapes. And I'm curious, you can see here in the cylinder, I have one method called getVolume. Can you see it? GetVolume. This method is specific to the cylinder. It's not available in the circle. Of course, it's not available in the shape. Now, in this general loop, you might say, oh, I have a problem now. How can I access you might be asking yourself, how can I access the getVolume? Can you see it here? If I do here shape.getVolume, say I don't know what you're talking about. I am the superclass, I don't know this getVolume. Because remember, superclass has the common stuff. GetVolume is not common, so the shape is not aware of it. But I insist, I want to call the getVolume. Yeah. Now, how can I solve this problem?
Have an if statement for the volume.
Have an if statement for the volume? In what way?
Sorry, like if statement to check if the shape is cylinder.
Okay.
Then I can call the getVolume.
I can call the getVolume. Okay, that's good strategy. So what I can do, I can come here and ask the shape. Ask the shape, are you a cylinder? How do I ask the shape, are you a cylinder? Can I type here, are you a cylinder? Of course, the Java is still not talking human language. Luckily, there is an operator built in Java called instance of. And here I put the class name. So this is asking, what this statement is asking, are you a cylinder? Is this particular shape I have at hand from the list, is it a cylinder? If it is cylinder, what happened to this statement? It will be true.
Yeah.
The statement will be true, and then I'll enter inside the if block. Now, is this solved my problem?
Yeah.
Can I see the volume?
Yeah. Yeah. Before the last one.
No. Oh, sorry. It's just the Eclipse is trying to be ahead of me. Okay. No, here is not ahead of me. Okay, it's just trying to be too smart. Anyway, this doing shape instance of does not solve my problem. The get volume is still not visible, which makes sense because it's not defined in the shape class. But I'm still insisting I want to call my get volume. So how do I do this?
Uncast it just like the
Sorry?
Cast it.
Yes, so I need to kind of convert it. It's kind of burnt my story. So what I will do, I'll take the shape, convert it to a cylinder. This is how I kind of cast. This is called downcasting. I bring it down, convert it from a shape to a subclass, which is the cylinder. And now I put all of this between parentheses. So, and now the cylinder class becomes visible. Can you see the volume there? The volume is now there. So the power of this, look at this. You can still do general coding applicable to all shapes, but in case you want to do something specific, you can also do it. But be careful, don't just go and do it immediately. Check before you act. Ask first the shape nicely. Please, are you a cylinder? If they say yes, then convert them to a cylinder and call the method you want. Okay, so I can basically show you here, if I come here and put this one here, I can just for simplicity, I will say cylinder volume. Yeah. Now if I run this, you can see a circle, I don't get that extra line. Cylinder, I get the toString, I get the cost, I get this extra line, the volume. Yeah. And for the second cylinder, I get that extra line. For the rectangle and for triangle, I don't get the volume. Yeah. So this is a nice kind of mixing the general coding with the specific. But with the specific, you need to be careful. So if I do something like this, let me try. If I don't check before I act, if I change lane, if I'm driving, I just change lane. Whenever I want to change the lane, just change the lane. I don't check anything. So what will happen? If you change lanes without checking, of course, crash will happen at a certain stage. Yeah, this is exactly what's happening. And this is an evidence that this is happening at a runtime. The compiler did not pick up this error, did not pick it up, because this is happening at a runtime. At a runtime, before you cast, you cannot cast circle to a cylinder. Before you do this, make sure you check. How do you check? By asking. Are you an instance of a particular class? How do I ask if an object is an instance of a particular class? By doing the object instance of followed by the class name. If this is true, it will be. If this is true, you get true and you get inside the if block. Otherwise, you will skip the if block. Clear? All right. So although polymorphism allows me to do program in the general, and it allows me to easily extend my program, but that does not mean I cannot access the methods of the subclasses. If I wish, I can, but first I need to make sure they are of the type that I desire. Another poor way of doing it, you can go to the object and say get class name equal the class name. That's not a good way of doing it. The best way of doing it is using instance of. And then you make use of downcasting. Downcasting is this part. You're basically converting a member to an instructor, and here converting a member to a student. So in this case, for example, I want to access the get office, which is not every member in QU has an office. Only the instructors have an office. So before I access the get office, I'll check if member is instance of instructor, then I cast it to instructor and call the get office. Now, not everyone has a GPA, current GPA. I mean, they are still working on it. It's dynamic and changing. Some people's GPA is static, finished. But the members that have an active GPA is instance of student. So before I call get GPA, I check whether that member is a student, and then I downcast it to students, and then I call the get GPA. Downcasting, clear? All right. Now, polymorphism, as I explained in the beginning, you can do it in two ways in Java, either using abstract classes or using interfaces. Now, for abstract classes, we already know the idea. So the abstract class, you can think of it as a template. So the abstract class has common attributes and common methods. And even the methods that there is no generic implementation for them, you can add them, no problem. But just mark them as abstract. Mark them as abstract. So abstract classes can contain implemented classes and abstract methods. Sorry, abstract class can contain implemented methods and abstract methods. But if you have one method that is abstract, of course, the whole class becomes abstract. So you can see here, the way I do it, I come to the class and mark it as abstract if one of the methods is abstract. Yeah. Okay, so the motivation here is to guarantee that all subclasses will contain some methods. So because in shape, for example, I have the get area, I am guaranteed, this is 100%, all subclasses will have the get area implementation because they are forced to. But I'll show you here. If I go to the circle, and then I will comment this out. Once I do this, no, sorry, not this one. This one is fine. It's yours. You can comment it. It's up to you. But in this one, if I take this and comment this one, once I comment this, the compiler is now upset. What's upsetting the compiler? The circle must implement the inherited abstract method get area. Yeah. How dare you? You are not implementing what I asked you to. Okay? That's what the compiler is saying. Abstract means you said you will extend the superclass. It is abstract. You are committed to implement all abstract classes. Otherwise, the compiler will be certainly upset with you. So let's not upset the compiler and make sure you implement all the subclasses. Sorry, all the abstract methods. Make sure we implement all the abstract methods in the subclasses. So this will allow us to enforce a common design that all subclasses have a particular method. And of course, it allows us to process these objects polymorphically. You're already familiar with this big term, polymorphically. Yeah? I declare the variable as a super type, and I call this abstract method on the super type, and at runtime, the system will work out which implementation to call. This is what polymorphically means. So we're already familiar with this. We know what this means. Okay. So we know what this means. I mean, the get area is super clear that we already did. Employee, for example, the employee, we have two types of employee. We have the part-time employee, we have the full-time employee. Now, the part-time employee have an hourly rate. So we take the hours they worked multiplied by hourly rate, we know their salary. While the full-time employee, they have a weekly or a monthly rate. And then we just pay them that monthly rate. So the compute pay is there is no generic implementation. So it will be abstract in here, but we have to implement it in each of those subclasses. So for the shape, I already explained in the get area is abstract in the shape, and when we extend the shape, we have to implement the get area. Okay. Once we do this, abstract classes plus polymorphism allows us to do generic programming. So for example, in here, what I'm doing, I'm creating an array, and the type is shape. I am storing multiple subclass instances in this array, and then looping through them and calculating the total surface or the total area. That's one example of making use of the abstract classes plus polymorphism to achieve our goal in one simple loop, that is general loop, that can handle all shapes.
Can we use a lambda or like stream to compute this?
Yes, of course. Yes, we can use a lambda, yes. Good question. I just didn't have the chance. Maybe as an improvement, I can put a lambda here. This is good point. We shouldn't do this. This one should be a lambda, a reduce. We do a reduce and we get it. Yes, good point. Make it. Yeah, no problem. Okay. One more things for the classes. There are some modifiers that we have not seen so far. Public we already seen. So class, if it is public, then it's accessible outside the package. If it's not marked as public, then it is only accessible within the package. So most of the classes we have seen so far, they are public. But if you make them not public, so they won't be accessible outside the package if you don't put the keyword public. Now, the keyword abstract, if you put it in the class name, before the class name, if you say public, abstract, and then the class name, the class will become abstract, which means you cannot create an instance of it. Finally, you can put the keyword final in front of a class. What does final mean? You cannot inherit from it. Take a look at this. If I come here to the circle, let me first make sure the compiler is happy. If I come to the circle and come here and mark this circle as final, I think we put it in here before the keyword class. Take a look at this. Now this guy is upset. The compiler is upset. Why? I mark this class as final, which means you are not allowed, nobody is allowed to inherit from it. And what the cylinder is doing, it's trying to inherit from circle. And what the compiler is saying, the type cylinder cannot subclass the final class circle. Simple as this. Okay? So if you mark a class as final, then you cannot extend it anymore. So let's remove this restriction, remove our here, and then we cannot do this, okay? By the way, for example, if I go here and do string, if I want to extend the string class, it's not allowed because string is final. You see here, cannot subclass the final string. You see, this is a built-in class in Java, but they marked it as final, which means no one is allowed to extend the string class in Java. So if I go here, you see here, this is the Java people code. What they marked this class as final. What does that mean? Cannot be extended. That's it, cannot be extended. You cannot derive anything from it. That's what final means.
What happens in the program? when the final is created? When the markup class is final, what happens?
What happens is that nothing happens except that the compiler will not allow anyone to extend that class. You cannot use it after extend keyword. That's all. Otherwise, there's no other impact. So except the class becomes non-extendable. Remember, we see this finally. If we put it in front of a variable, what does that mean? It's a constant. Yeah? If we put it in front of a method, what does that mean? Cannot be overridden. Thank you very much. Cannot be overridden. Yeah. So if for some reason, of course, it doesn't make sense. I think this doesn't make sense. I think even the compiler will be laughing. Final. Say you are contradicting yourself. You are saying abstract and final. It doesn't make sense. Yeah. So final method cannot be basically overridden. Okay. Okay, so final class cannot be extended, final method cannot be overwritten, and a final variable cannot be changed because it's constant. So inshallah, next time I want to introduce the interfaces.